Module 7. In this part of the course, we'll introduce you to the concept of forced browsing. Forced browsing is not technically a vulnerability nor an attack. The term is simply descriptive of a situation where a user doesn't browse through web application resources by clicking URLs, but accesses content by manual identification of resources and may gain access to restricted parts of a service. Imagine a company that sends client emails linking to a page containing sensitive data like the client's personal information, account balance, and so on. This could look something like this. What's immediately striking is the identifier contained in the path. It's a numerical value and could easily be substituted for another parameter. As you can see, changing this parameter will display private information of another client. This could constitute a breach of the Personal Data Protection Act or lead to the leaking of valuable personal data of the company's clients. Another instance of forced browsing is the identification of vital service directories which store libraries, configuration files, and other files used to dynamically generate content. These files should be restricted from final users, as accessing them could lead to errors that result in leaking sensitive data or the script acting autonomously in ways that were not provided for by the application developer. If access to these files is not authorized in any way, forced browsing may also constitute an example of data hiding. Web developers want to restrict users from accessing files, but don't use any other methods of preventing this. In the case of web applications, developers often use common directory names to store service files. An example of such a directory is lib, which could contain library classes or full libraries used by a web application. Another directory is classes. You can also see here unsecured files, which, in isolation, could lead to displaying errors. Other examples are include and includes. The include directory doesn't exist in the service, but you can access the includes directory, which often contains configuration files. If the data is stored in a file whose extension is not linked to any interpreter, or the data is contained in INI or XML files, a user may be able to see the contents of the file and, for example, discover database credentials. Since the consequences of forced browsing could be very serious, you need to remember that while building a web application, you should never simply assume a visitor won't be able to access certain parts of the service. All directories have to be secured, and directories containing data which is only used server-side should be located outside the web server or blocked in an htaccess file. You also need to remember that incorrect file extensions could lead to the leaking of crucial data, like configurations or service source code. Finally, while displaying data to restricted groups of users, don't solely rely on line-generated identification numbers. It might be a better idea to use hash functions to generate less predictable identifiers. Better yet, be sure to implement cutting-edge authorization mechanisms in your application. That's all in Module 7. Welcome to Module 8 of our course. In this module, we'll focus on path traversal. A path traversal vulnerability occurs where a user may alter the parameters referred to a web application to determine which files could be loaded by the application. Let's take a look at a sample source code illustrating the vulnerability. You can see here a simple website created in PHP. The contents of the subpage are loaded from a file stored outside the web root directory. As we can see, get is used to pass the name of the file which will be displayed. The file getContents function retrieves the content of the file but doesn't parse it. Notice that an attacker is able to freely manipulate the name of the file which will be displayed by the application. We can see here a website which is working normally. The address bar contains the variable site, which is used to specify a loaded file. Let's see what will happen if we submit the index.php file as a parameter. Take a look at the source code of the page. We can see here the source code of index.php. This is extremely dangerous, since an intruder may use the information to find other code vulnerabilities, or display configuration files that contain critical data like passwords to databases, mail servers, or FTP. Let's try to think of other ways in which an attacker could exploit this vulnerability. Insert the name of a non-existing file. The returned error information contains the full path to the page file. This is an example of a path disclosure vulnerability, which was discussed earlier. We also know that the web server of the site is Apache in the XAMPP framework. This helps us guess the location of the PHP ini. The string ./ passed at the beginning to the file getContents function in theory restricts the access to the current directory. In practice, by using standard special directories ... you may be able to navigate to parent directories. In this case, we'll climb 5 directories up. As you can see, the contents of PHP ini have been displayed. Using this method, you can access virtually all files stored in the web server, provided that their location is known and they may be accessed by a PHP interpreter. This is an extremely serious attack, which could lead to the disclosure and leaking of critical information concerning the server or the web application itself. Let's see how we can protect ourselves. Whitelisting consists of creating a list of files which can be accessed by a script and comparing the files selected by a user against the list. Another form of whitelisting is specifying the characters expected to be present in the inputted file name. If a user-provided parameter doesn't conform to the specifications of the whitelist, the file will not be read. Unfortunately, this solution is either impossible to implement or simply impractical. As you can see, in this case, an attacker even has control over the file extension. Let's try to predefine the extension. We'll modify the existing instances. After a restart, we can see that the extension has been added permanently to the end of the string passed to the file getContents function and may not be manipulated by potential attackers. In PHP editions older than 5.5.3, it was possible to pass the end of string marker %00, which was included without validation in the string passed to file getContents. This enabled an attacker to delete the added extension. The problem has been solved in newer versions of PHP. In a word, it's important to employ protection mechanisms to prevent hackers from reading restricted directories, even if we assume that the files with allowed extensions won't contain critical data. Filtering out the dot and dot// characters may also be useful. Let's now try to implement this mechanism. The function will delete the dot and / characters. Let's see if this is enough as a security measure. As you can see, all dot and / characters have been deleted, which certainly makes it harder for potential hackers to attack our application. Remember that there's always a risk present if users are able to modify application parameters to change the name of the processed file. That's why all input parameters must be treated with extra caution and be properly filtered. That's all for Module 8. Thanks for your attention, and see you in the next part of the course.